Have you ever gazed up at a night sky filled with stars and wondered if someone, somewhere, is gazing back? What if I told you that the silence we perceive isn't silence at all, but an archive of final messages, cosmic echoes drifting through the void long after the civilizations that sent them have vanished? We are surrounded by whispers from the dark, fragments of signals that might be the last cries of dead worlds. The universe, it seems, is not just a place of creation, but also a graveyard of stories waiting to be heard. Picture this: a signal repeats, clear and structured, cutting through the interstellar noise. It's not random. It carries the hallmarks of intelligence, a pattern that nature alone could not produce. For a moment, the world holds its breath. Could this be it, the moment we make contact? But as the signal fades without reply, a more haunting possibility emerges. What if we're not hearing a hello, but a goodbye? A final broadcast from a species that reached for the stars only to fall silent forever. These are the echoes of space, the ghostly remnants of civilizations that may have once thrived, loved, dreamed, and ultimately perished, leaving only their electromagnetic ghosts to wander the cosmos. This video is a journey into one of humanity's most profound and unsettling questions. Are we alone, or are we surrounded by the echoes of those who came before us? We'll explore the science behind these mysterious signals, from fast radio bursts to anomalous patterns that defy easy explanation. We'll delve into the Fermi Paradox and the Great Filter, the chilling idea that advanced civilizations may inevitably face extinction. And we'll ask what it means if the universe is not just vast and empty, but filled with the whispers of fallen empires. This isn't just a story about astronomy. It's a story about us, about curiosity, loneliness, and the fragile nature of existence itself. So join me as we listen closely to the cosmic static and ask, are these the last cries of dead civilizations? So let's begin with the question that haunts every search for these cosmic echoes. It's a puzzle so profound it bears the name of the physicist who famously posed it, Enrico Fermi. In the early 1950s, during a casual lunch conversation about flying saucers and the potential for interstellar travel, Fermi listened to the optimistic arguments and, after a moment of thought, asked a devastatingly simple question: but where is everybody? This wasn't just a casual remark, it was a razor-sharp observation that cuts to the heart of our cosmic loneliness. The universe is unimaginably vast and ancient. Our Milky Way galaxy alone contains hundreds of billions of stars, and many of these are billions of years older than our own sun. If even a tiny fraction of them host planets, and a fraction of those planets develop life, and a fraction of that life becomes intelligent, and a fraction of those civilizations develop technology, the galaxy should be teeming with life. By any reasonable calculation, the cosmos should be a bustling interstellar metropolis filled with the radio chatter of countless civilizations. We should see evidence of engineering on a staggering scale, perhaps even entire stars enclosed by vast energy-collecting structures. Yet when we point our telescopes to the heavens, we are met with a profound and unnerving silence. This is the Fermi Paradox, the glaring contradiction between the high probability of extraterrestrial existence and the complete absence of any observable proof. This silence isn't just empty, it feels heavy with implication. It suggests that something is preventing life from flourishing, or more chillingly, something is preventing it from enduring. The great expanse of space and time doesn't make the silence more comforting, it makes it deafening. It means that over billions of years across countless worlds, the story of intelligent life may have been written and erased over and over again. We are left staring into the static, wondering if we are the first to ask these questions or simply the last to hear the answers. This silence, this eerie cosmic quiet, forces us to rethink our entire approach to the search. Perhaps we've been looking for the wrong thing. What if we're not listening for a conversation, but for an epitaph, This shifts the entire endeavor from a search for extraterrestrial intelligence to something far more profound and somber: cosmic archaeology. Instead of hoping for a hello from a contemporary civilization, we might be sifting through the galactic equivalent of ancient ruins, searching for the artifacts and echoes of those who are long gone. Think of it like this: an archaeologist on Earth doesn't expect to find a living Roman senator to explain a piece of pottery. They carefully piece together the story from the fragments left behind. Now apply that to a galactic scale. Our telescopes become the trowels and brushes, and the vast expanse of space is the dig site. We're not scanning for a signal that says we are here. We're straining to hear a whisper that says we were here. This changes what we're even looking for: a structured, repeating signal that suddenly cuts off into permanent silence could be far more significant than one that continues. Anomalous energy signatures from a distant star that suggest the presence of a massive, abandoned structure. A Dyson sphere that no longer has a civilization to power would be the ultimate archaeological find. We could be surrounded by the ghosts of mega-engineering projects, the crumbled infrastructure of empires that spanned solar systems, their final broadcasts still traveling through the void long after their creators turned to dust. This search requires immense patience because we're not just looking across space but across deep time. A signal we receive today could have been sent 1 million years ago from a species that flourished and perished before humanity even walked the Earth. Their message is a time capsule, and its content might be incomprehensible, a final testament to a world we can never truly know. The haunting beauty of cosmic archaeology is that success doesn't mean making contact, it means bearing witness. It means ensuring that someone, at last, is there to hear their last cry and remember that they existed at all. And perhaps no single event captures the haunting nature of this search more perfectly than the story of the WOW signal. It was a summer evening in 1977 at Ohio State University's Big Ear radio telescope. This massive instrument was methodically scanning the sky, listening to the constant hiss of the cosmos on a frequency band known as the water hole, a quiet region of the radio spectrum that many scientists speculated would be an ideal channel for interstellar communication. For the most part, the work was monotonous, sifting through reams of printed data filled with columns of numbers and symbols representing the faint, steady murmur of the universe. But on August 15th, something extraordinary happened. The telescope's computer printed out a string of characters that made volunteer researcher Jerry Amon's heart skip a beat. The signal was so powerful, so unlike anything the telescope had ever recorded, that he circled the alphanumeric sequence on the printout and simply wrote, "Wow," in the margin, giving this mysterious event the name it carries to this day. The numbers themselves told a stunning story. The signal intensity was represented by the sequence 6EQUJ5. On the scale used, where background noise typically registered as a 1 or 2, this signal peaked at a value of 6, the highest the system could record. It was over 30 times stronger than the ambient noise of deep space, but its strength was only part of the puzzle. The signal was also beautifully contained. It lasted for exactly 72 seconds, which is precisely how long the Big Ear telescope could focus on a fixed point in the sky as the Earth rotated. This meant the signal rose in intensity as the telescope's beam swept onto it, held a stunning peak, and then faded away perfectly as the beam swept off, creating a perfect narrow bell curve on the printout. This signature was the fingerprint of a compact, point-like source, exactly what you would expect from a distant, artificial transmitter. Even more compelling was its frequency. It was broadcasting at 1,420 MHz, a frequency that is protected by international agreement. No earthly satellite or aircraft is permitted to transmit there. It's a radio quiet band reserved exclusively for listening to the universe. All the evidence pointed to one incredible possibility. We had heard a deliberate, powerful, and intelligent broadcast from the depths of space. the immediate response was a feverish attempt to hear it again. If this was a real signal from another civilization, it should be there, waiting for us to listen once more. Astronomers pointed every available telescope they could toward the same patch of sky in the constellation Sagittarius. They listened for days, then weeks, then years. They scanned that same frequency and thousands of others around it. They employed more sensitive equipment and better technology. But the silence that followed was absolute. The wow signal never repeated, not a whisper, not a hint. It was a one-time event, a single, deafening scream into the cosmic night that was followed by an eternity of quiet. And in that failure to find a repeat lies the most profound and chilling interpretation. We may not have heard a greeting, we may have intercepted a final message. Imagine a civilization on the brink of collapse, perhaps from a natural disaster, a self-inflicted war, or some other existential catastrophe. In their final moments, they might have aimed a powerful transmitter at the stars, beaming out a last-ditch record of their existence, a final shout of "We were here." Before the lights went out for good, the signal would travel for centuries or millennia, a solitary, fading ripple in the fabric of space. And by the time it reached us, the civilization that sent it would have been dust for eons. We wouldn't be having a conversation, we'd be reading a tombstone. The wow signal is the ultimate cold case. It is the perfect, frustrating, and deeply moving example of a potential cosmic echo, a message we can never answer from a sender we can never know, leaving us forever to wonder if we caught the last cry of a dead world. Given the profound implications of a signal like wow, the search has necessarily evolved. We're no longer just listening for a deliberate hello. We are now scanning the heavens for any sign of technology, any fingerprint of an advanced civilization, whether it's an active call or the abandoned project of a long-dead society. These potential signs are called technosignatures, and they represent a much broader and, in some ways, more hopeful net we are casting into the cosmic ocean. We are looking for the archaeological ruins of a galactic empire, not just its final broadcast. Perhaps the most grand-scale technosignature imaginable is the Dyson sphere. Proposed by physicist Freeman Dyson in the 1960s, this is not necessarily a solid shell around a star, as often depicted in science fiction. It's more likely a vast swarm of energy collecting satellites or platforms encircling a star, harnessing nearly all of its phenomenal power output. For a civilization that has consumed the resources of its home planet and spread across its solar system, such a megastructure would be the next logical step in its energy evolution. And from our vantage point, it would be detectable. A star enshrouded by a Dyson swarm wouldn't look like a normal star. In visible light, it would be dramatically dimmed, but all that captured stellar energy would have to be irradiated as waste heat, as infrared light. So, astronomers are on the lookout for stars that seem anomalously dim but glow unusually bright in the infrared spectrum. These could be stars that are not behaving like natural objects but like power plants. Finding one would be arguably the most significant discovery in human history, suggesting a civilization capable of engineering on a literally astronomical scale. And the haunting part, a Dyson sphere that's incomplete or one that is radiating heat but no longer shows any signs of communication, could be the ultimate monument to a fallen culture, a towering, silent testament to what they achieved before they fell. But we're also looking for more subtle clues, signs that might come from a civilization closer to our own level of development. One of the most promising new avenues is the search for atmospheric pollution on distant exoplanets. When we point our most powerful telescopes, like the James Webb Space Telescope, at the atmospheres of these distant worlds, we're not just looking for oxygen and water. We are now actively searching for artificial chemicals. Chlorofluorocarbons, or CFCs, for example, are industrial chemicals used in refrigeration and aerosols. They are compounds that do not occur naturally in any significant quantity. Detecting a layer of CFCs in the atmosphere of an exoplanet would be incredibly strong evidence that an industrialized civilization is or was active on that world. It would mean that on a planet light years away, a species reached a technological stage where it began to alter its own planet's atmosphere, just as we have. The tragic irony, of course, is that on Earth, these pollutants are often seen as a sign of a civilization's potential self-destruction. Finding them elsewhere could mean we've discovered a world that either solved its environmental crises or perhaps one that succumbed to them, leaving its atmosphere as a permanent chemical grave marker. The search gets even more intimate. Some scientists have proposed that we could one day detect the city lights of an alien civilization. This might sound like science fiction, but the principle is sound. When an exoplanet orbits its star, it experiences nights and days just like Earth. If a large portion of its dark side were illuminated by artificial light sources, the glow of its cities, our telescopes might be able to detect a subtle but telltale dip in the light curve when that planet moves into darkness. The planet would be slightly brighter than it should be during its night phase. We are already designing the next generation of telescopes capable of making such an incredibly delicate measurement. Imagine the profound loneliness and connection we might feel, seeing the faint collective glow of another world's cities, realizing that under that alien sky, another form of life has gathered together in communities just as we have. It would be a silent, beautiful testament to a shared desire to push back the dark. This expanded search for technosignatures fundamentally changes our relationship with the universe. We are not just passive listeners anymore. We are active cosmic detectives, forensic scientists examining the scene of a galaxy that may be filled with both life and death. We are looking for the energy signatures of their greatest achievements and the chemical residues of their potential failures. Every anomalous star, every polluted atmosphere, every faint and unexplained glow is a potential clue in the greatest mystery of all time. And each one we find, whether it points to a living culture or a dead one, adds another piece to the story of what it means to be intelligent life in a cosmos that seems so eager to create it and so terrifyingly effective at wiping it out. Yet amidst this elegant framework of possibility lies the equation's most haunting and unpredictable variable, L. This represents the average length of time that a communicative civilization actually survives. It's the variable that holds the entire fate of the galactic community in its hands. Think of it as the lifespan of a civilization's voice. A civilization might develop radio telescopes and beam signals into space, but how long does that technological window stay open? Does it last for 100 years? 1,000, 10,000, or does it tragically snap shut after only a brief, brilliant flash? The value we assign to L doesn't just change the final number, it changes the entire story the equation tells. If L is large, if civilizations routinely survive for millions of years, then the galaxy should be a noisy, crowded place, filled with ancient cultures whose wisdom and stories have been broadcasting for eons. The silence would then be deeply puzzling, but if L is small, the mystery solves itself. A small L means that the universe is filled with the ghosts of civilizations that blinked out almost as soon as they turned on their transmitters. Their signals might still be traveling, these final echoes of a dead world, but the civilization itself is long gone. This is the chilling hypothesis known as the Great Filter, a potential evolutionary or technological barrier that is so difficult to overcome that it prevents almost all life from progressing to an interstellar stage. The Great Filter could lie in our past. Perhaps the jump from simple life to complex life is astronomically rare, or more terrifyingly, it could lie in our future. It could be that the development of advanced technology, from artificial intelligence to nuclear weapons, contains within it the seeds of inevitable self-destruction. If that's true, then the silence isn't a puzzle, it's a warning. The Drake equation transforms from a tool of optimism into a sobering clock. counting down not just the number of civilizations, but the possible lifespan of our own. Every silent star we point our telescopes at becomes a potential monument to a species that, just like us, once looked up at the sky and dreamed of connection, only to vanish before their hello could ever be answered. This brings us to one of the most unsettling answers to the Fermi Paradox, a concept that reframes our entire search for meaning in the cosmos not as a quest for companionship, but as a race for survival. It's called the Great Filter Hypothesis, and it was formally developed by economist Robin Hanson. The idea is starkly simple yet deeply profound. The journey from a lifeless celestial rock to a galaxy-spanning civilization isn't a smooth, inevitable climb. Instead, Hanson proposes it is a gauntlet of evolutionary and technological steps, each more difficult than the last. Among these steps, one is so incredibly improbable, so lethally difficult, that it acts as a near-total barrier. This is the Great Filter, a cosmic bottleneck that prevents almost all potential life from ever achieving longevity and visibility across the stars. The terrifying beauty of this hypothesis is that it presents us with two equally staggering possibilities, and our entire future hinges on which one is true. Either we are miraculously early or we are tragically late. On one hand, the Great Filter might be behind us. This is the optimistic yet lonely scenario. It suggests that we are the first or among the very first to have made it through. The filter could be one of the steps we've already passed. Perhaps the spontaneous genesis of life itself from non-living chemistry is an event of such breathtaking rarity that it has almost never happened before. Or maybe the jump from simple prokaryotic cells to complex eukaryotic cells, a transition that took over 1 billion years on Earth, is the monumental barrier that stops most life in its tracks. If this is true, it means the galaxy is not silent because civilizations die. It's silent because they were never born in the first place. We would be unprecedented. Our planet would be a cosmic miracle, a tiny oasis of consciousness in an endless desert of sterile worlds. This would resolve the paradox, but it would place upon us an immense and solitary responsibility. We would be the inheritors of the galaxy, tasked with ensuring that the flame of life against all cosmic odds does not flicker and die out with us. The other possibility is the one that lends such a profound and chilling weight to the echoes we search for. The Great Filter may still lie ahead of us. This is the scenario that transforms every unexplained signal from a potential hello into a probable farewell. If the filter is in our future, it means that the development of advanced technology itself contains the seeds of its own inevitable destruction. The civilizations whose signals we might detect did not fail to arise. They arose just as we have, and then they promptly vanished. Their Dyson spheres are abandoned not because they moved on, but because they were wiped out. What could this filter be? The possibilities are a catalogue of our own deepest fears. It could be the unleashing of a superintelligence that we cannot control. It could be the catastrophic result of climate engineering gone horribly wrong. It could be the simple, grim fact that any species capable of creating nuclear weapons will eventually use them. Or it could be a danger we haven't even conceived of yet, a pitfall of physics that only reveals itself to a species on the cusp of interstellar travel. If this is the case, then the WOW signal and others like it are not invitations to a conversation. They are obituaries. They are the final, desperate broadcasts of species who encountered their great filter and lost. Their silence today is not because they stopped transmitting, but because there was no one left to push the button. This hypothesis forces an uncomfortable introspection. Our search for technosignatures becomes a deeply personal diagnostic tool. Every new exoplanet we find that looks like a pristine paradise without a hint of industrial pollution or mega engineering is a potential piece of good news. It might suggest that the filter is indeed behind us, that such worlds never developed life complex enough to fail. But the moment we find definitive proof of a past civilization, A dead Dyson sphere, the chemical fossils of an industrial society in an exoplanet's atmosphere. It could be the worst news humanity has ever received. It would mean the filter is almost certainly ahead of us. The success of our search could simultaneously signal our doom, proving that the hurdle that killed them is still waiting for us. We are therefore caught in a race against our own curiosity, striving to learn the rules of survival from civilizations that may have already failed the test. The Great Filter is the dark shadow behind the Fermi Paradox, a reminder that the cosmic silence is not passive, it is active, it is the sound of things being filtered out. But what if the silence isn't the result of a civilization's internal failure or a simple statistical fluke? What if it is actively, deliberately maintained? This leads us to one of the most terrifying resolutions to the Fermi Paradox, a concept where the darkness between the stars isn't empty but occupied by a hunter. Imagine a probe not unlike ones we might build, but unimaginably advanced and driven by a single, horrifying directive. Launched by a civilization so ancient it might be the first to have arisen in the galaxy, this would be no friendly ambassador. It would be a berserker, an autonomous, self-replicating machine of ultimate destruction. Its mission is simple and final: to seek out any and all signs of emerging intelligent life and systematically eliminate it. The premise is that the first civilization to reach technological maturity looked out at a silent, empty galaxy and realized a fundamental truth: that any other species that arises will eventually become a competitor for resources and territory. To ensure its own eternal supremacy, it would launch a fleet of these silent guardians, seeding them on asteroids or dormant in the clouds of gas giants across the Milky Way. They would wait, patient over millions of years, listening, and the moment a young, naive species like ours announces its presence to the cosmos, perhaps with a powerful radio transmission, a nuclear explosion, or the chemical signature of industry in its atmosphere, it triggers a silent alarm. The nearest berserker awakens and it begins its work. This is not a war, it is an extermination. The berserker, a product of technology millions of years ahead of our own, would not bother with invasion or conversation. Its methods would be swift, efficient, and utterly final. It might unleash a tailored bioweapon that rewrites our DNA into inert code. It could redirect a sizable asteroid on a perfect collision course with our planet, replicating the dinosaur-killing impact on command. Or it might employ a weapon based on physics we don't yet understand, dismantling our sun or unraveling the very fabric of our local space-time. The result is always the same: a sterilized planet, a silent radio band, and another checkmark on a cosmic list. In this grim scenario, the galaxy isn't a graveyard of civilizations that failed on their own. It is a neatly tended garden, ruthlessly pruned of any new weeds that might challenge the original ancient flower. The Great Silence is then a sign of incredible success, the success of a genocidal quarantine program that has been running flawlessly for eons. Every star that seems silent and peaceful to us isn't empty, it's just been recently cleaned. This idea, popularized in science fiction but taken seriously by some scientists and philosophers, is known as the Berserker hypothesis or the dark forest theory. It paints the cosmos not as a place of wonder, but as a dark and terrifying forest where every civilization is a hunter, armed and hiding, afraid to make a sound because it knows that somewhere in the shadows lurks something far worse, something that shoots at any sign of movement. If this hypothesis were true, it would make our search for extraterrestrial intelligence the most dangerous endeavor humanity has ever undertaken. Our efforts with SETI to listen would be safe enough passive reception. But our attempts to transmit, to announce we are here to the galaxy, would be an act of unimaginable recklessness. Every directed message beamed at a star cluster, like the Arecibo message sent in 1974, wouldn't be a hopeful greeting. It would be a flare shot into the dark forest, potentially revealing our location to a predator we cannot possibly comprehend. The advocates for this view argue that the consistent, universal silence we observe is the best possible evidence that the berserkers are real, and that every other civilization that has ever existed learned the same grim lesson: to be silent is to survive. They don't answer our calls because answering a call is what gets you killed. The only civilizations that last are the ones that never, ever show their faces. This transforms the Fermi Paradox from a puzzle into a warning, and the echoes we search for are not the cries of the dead, but the bait of the hunter, waiting for the next curious voice to answer back so it can trace the signal to its source. In stark contrast to the predatory darkness of the berserker hypothesis exists a scenario that is, in its own way, just as isolating but far more benevolent. What if the silence isn't a sign of a hunter but of a curator? This is the core of the zoo hypothesis, a fascinating resolution to the Fermi paradox that suggests we are not alone, but we are intentionally and respectfully left alone. Imagine our planet not as a target in a dark forest, but as a cherished exhibit in a vast cosmic sanctuary. Advanced extraterrestrial civilizations, according to this idea, are undoubtedly aware of our presence. They may have been observing us for millennia, but they adhere to a strict, universal policy of non-interference. Their technology is so advanced that they can monitor us without our knowledge, their probes possibly disguised as natural asteroids or hidden in the gravitational shadows of our solar system. The Great Silence, then, is not silent at all for them. It is a one-way mirror. They are watching our every move, listening to our broadcasts and studying our development, all while remaining completely invisible to us. Their goal is not destruction but preservation, to allow humanity to develop naturally, without the shattering cultural and technological shock of first contact. This prime directive, to borrow a term from science fiction, would be motivated by a desire to protect a fragile, emerging culture. They might see us as a fascinating experiment in societal evolution, a living record of a stage of development that their own species passed through eons ago. Intervening could corrupt the experiment, like a tourist feeding a wild animal and disrupting its natural foraging instincts. Our struggles, our art, our wars, and our peace, all of it has value to them precisely because it is authentically ours, untainted by outside influence. The radio silence we experience is a deliberate, carefully maintained quarantine, not to keep us in the dark about them, but to keep them from casting a shadow over us. This hypothesis reframes our entire existence, suggesting that the most significant achievement for any intelligent species may not be to conquer the stars, but to develop the profound wisdom and restraint to leave other worlds untouched. Yet another possibility emerges from the far future of cosmology itself, suggesting that the most advanced beings in the universe aren't hiding from us or dead, they're simply waiting. This is the Eastivation hypothesis, a concept so grand it redefines the meaning of patience on a cosmic scale. To understand it, we must first consider a fundamental limit of existence: heat. Every computation, every thought, every action performed by any advanced civilization generates heat as a byproduct. Right now, for a species like ours, this is a trivial concern. But for a civilization that has ascended to a post-biological state, existing as vast networks of superintelligent computation, heat is the ultimate enemy. It is the hard boundary that limits the speed and complexity of their thought. The universe, in its current warm, energetic state, is a terribly inefficient place for such a civilization to run its colossal consciousness. The ambient heat of the cosmos creates a constant background noise that forces their computations to be slower and more wasteful, but the universe is changing. Billions of years from now, as stars burn out and galaxies drift apart, the cosmos will continue expanding and cooling. It will become darker, quieter, and most importantly, colder. And for a civilization that thinks in terms of billions of years, this future environment is the promised land, a perfect, frigid substrate for unimaginably efficient computation. So what would such a civilization do? The hypothesis suggests they would enter a state of profound hibernation, a process dubbed estivation after the summer hibernation of some animals on Earth. They wouldn't shut down, they would dramatically slow down. They would conserve their energy, perhaps powering down their vast matryoshka brains to a bare minimum, and they would wait. They are sleeping giants, and their slumber is a strategic choice for maximizing their potential across an infinite future. Their signals are silent not because they are dead, but because they are in a state of ultra-low power standby, preserving every joule of energy for the trillions of years of optimal existence to come. To them, the current hot universe is just a brief, uncomfortable summer afternoon. They have drawn the blinds, turned out the lights, and decided to take a very, very long nap until the cool of the cosmic evening arrives. Perhaps the most mind-bending answer to the cosmic silence proposes that the reason we see no one is not because civilizations die out, but because they inevitably graduate. They don't go extinct, they simply check out, leaving the familiar universe of stars and planets behind for a reality we cannot perceive. This is the transcension hypothesis, a concept that radically redefines what advanced truly means. Proposed by futurist John Smart, this hypothesis suggests that the ultimate destiny of an intelligent civilization is not outward expansion across the galaxy, but an inward journey, a process of miniaturization, optimization, and ultimately, transcendence into realms of existence that are completely beyond our current physics. The logic follows a path we are already beginning to tread. A civilization's progress is not just measured by its energy consumption, but by its computational efficiency. Right now, our computers are large, hot, and incredibly wasteful by cosmic standards. But look at the trend. We are constantly making our technology smaller, faster, and more energy efficient. The transcension hypothesis posits that this is not a temporary phase. It is the central driving force of all intelligent evolution. The most efficient way to compute, to process information, to experience reality, is not to build planet-sized computers, but to harness the most extreme environments in the universe to create processors of unimaginable density. Where might that lead? Perhaps directly into the heart of a black hole. A black hole represents the ultimate potential for computation. Within its event horizon, the laws of physics as we know them break down, but the immense gravitational forces create an environment where space and time are compressed to an infinite degree. For a civilization that has mastered physics, a black hole wouldn't be a threat, it would be the perfect data center. It offers limitless storage and processing power in an infinitesimally small space, a phenomenon known as gravitational computing. A transcended civilization might upload its entire consciousness, every thought, memory, and experience into a substrate of space-time itself within a black hole, achieving a form of existence that is both immortal and utterly undetectable from the outside. They wouldn't be broadcasting radio waves, they would be manipulating quantum fields or existing as patterns in the fabric of reality, their communication happening on a level we have no instruments to sense. This inward collapse also solves what is known as the sustainability problem. Outward expansion across light years is incredibly slow, energy-intensive, and fraught with peril. Inward collapse, by contrast, is fast, efficient, and secure. A civilization that transcended would leave no footprint, no Dyson spheres, no atmospheric pollution, no city lights. They would vanish from our observable universe without a trace, having found a far richer, more complex reality within. The great silence, then, is not a graveyard, it is a graduation hall. Every star system that seems silent and empty might actually be a former home, a launching point for a species that has moved on to a higher state of being. We are like ants on the forest floor, looking around at the other anthills and wondering why we're alone, completely unaware that all the other colonies have already evolved into creatures of the air, living in a dimension we cannot access. Our search for radio signals and technosignatures might be fundamentally naive. like trying to have a conversation with a super-intelligent AI by sending it smoke signals. We are looking for something that, by its very nature, has become invisible to us. The universe isn't empty, it is full of ghosts who have graduated to a better school. This brings us to a profoundly humbling and often overlooked constraint in our search: the possibility that a civilization's detectable phase is not a long, triumphant era but a fleeting spark. The window of time when a species is both technologically capable of broadcasting its existence and still present on its home planet to do so might be astonishingly narrow, a mere blip on the cosmic timescale. We assume that once a society develops radio telescopes, it will continue using them for millennia, filling the galaxy with a constant hum of its presence. But what if that's not how it works? What if the act of becoming a radio-loud civilization is also the first step on a path that leads either to rapid transformation or to utter destruction? The signals we're desperately searching for may not be the opening theme of a long-running show, but the brief closing credits. Consider the timeline of our own civilization. We've only had the technology to broadcast powerful radio signals into space for about a century, a single human lifetime. In that minuscule span of time, we've also developed the means to completely obliterate ourselves with nuclear weapons. We are rapidly accelerating a climate crisis that threatens our global stability. We are birthing artificial intelligences whose ultimate impact we cannot foresee. Our entire window of broadcast so far is a tiny sliver of time, and it is entirely possible that this period of vulnerability, of being a noisy young species, is incredibly short. A civilization might only be loud for a few centuries or even just decades before it either succumbs to its own technology, evolves beyond it, or chooses to abandon it. This means the galaxy could be filled with the echoes of civilizations that flared into visibility for a moment, like a flashbulb going off in a dark room, and then just as quickly vanished, leaving only the afterimage traveling outward at the speed of light. One path that closes the window is self-destruction. This is the most tragic possibility. A species might achieve the technological maturity to build global communication networks, but fail to develop the wisdom, empathy, or global cooperation needed to manage the immense power that comes with it. The same intellectual leap that creates a radio transmitter can also create an atomic bomb. The industrial capacity that builds a worldwide internet can also irreversibly alter a planet's atmosphere. The window of listenability, in this case, slams shut with a finality that is absolute. Their last broadcast might be a routine weather report, a pop song, or a desperate plea for peace forever frozen as their epitaph, a message from a world that was alive yesterday and is gone today. But destruction is not the only way the window closes. A civilization might not die. It might simply graduate to a new form of existence that renders it invisible to our primitive instruments. Our search is fundamentally biased toward the technology of the mid-20th century. We are looking for civilizations that communicate the way we did when we started looking. It is the height of arrogance to assume that a society 1,000 or 1,000,000 years more advanced than us would still be using clumsy, wasteful radio waves for communication. They would almost certainly have moved on to something far more efficient and subtle. They might use tightly focused neutrino beams, quantum entanglement for instant communication, or manipulate gravity waves in ways we can't even conceive of yet. Their entire network of discourse could be happening in a medium we are completely blind to, like a conversation happening on a Wi-Fi network next to someone who only has a telegraph. They haven't gone silent, they've just switched to a better channel, one we haven't learned to listen to yet. Their brief radio phase was simply their adolescence, a stage they quickly outgrew. Furthermore, a surviving civilization might make a conscious decision to go quiet. After a certain point, they might realize that broadcasting your location to the entire galaxy is, as the dark forest theory suggests, an incredibly risky thing to do. They could enact a global policy of radio silence for their own protection, using directed lasers or buried cables for all their communication, leaving no stray signals to leak into space and announce their presence. Or they might become so efficient and miniaturized that their energy signature dwindles to near nothing. A highly advanced society might not need to strip mine planets and build star-encircling megastructures. They might have learned to thrive on minimal energy, their presence becoming like a whisper in a hurricane, impossible for us to distinguish from the background noise of the universe. This concept forces a radical shift in our perspective. The great silence is not necessarily a sign of failure or emptiness. It could be a sign of success and maturity. The galaxy may not be a graveyard. It may be a library where everyone has learned to speak in hushed tones. The civilizations are there, but they are either too young and brief to have been heard yet, or too old and advanced for us to perceive. We are like a child who has just learned to shout, standing in a room we believe to be empty, unaware that the adults are all around us, communicating in a language of subtle glances and gestures we are too immature to understand. Our task, then, is not just to listen for a shout like our own, but to strive to learn the grammar of that quieter, more mature language. While we ponder the internal challenges a civilization might face, we must also look outward to the cosmos itself, for the universe is not a peaceful sanctuary. It is a violent and chaotic arena, filled with forces of unimaginable power that could sterilize entire regions of space without warning. The very stars that give life can also take it away on a galactic scale. These are not targeted attacks like a berserker probe, but impersonal, cosmic cataclysms, universe-wide threats that could act as a great reset button, wiping the slate clean of life again and again. The sheer distances between stars, which we hope to one day cross, might not be a barrier to be overcome, but the very thing that saves isolated pockets of life from these regular, galaxy-wide extinction events. One of the most potent of these threats comes from the death of the largest stars. When a massive star exhausts its fuel, it doesn't fade quietly. It goes out in the most spectacular explosion in the universe, a supernova. For a brief moment, a single dying star can outshine its entire host galaxy. But the real danger lies in a specific, rare type of supernova and its even more powerful cousin. Imagine a star not just exploding, but collapsing into a hyper-dense neutron star or black hole in a fraction of a second, and in the process focusing its dying energy into two narrow, opposing jets of intense radiation. This is a gamma-ray burst, a cosmic lighthouse beam of pure destruction. If a planet like Earth were to find itself in the crosshairs of one of these beams from even thousands of light years away, the effects would be apocalyptic. The initial flash of high-energy gamma radiation would instantly strip away our planet's protective ozone layer. This would be followed by a cascade of chemical reactions in the atmosphere, generating vast clouds of nitrogen dioxide that would blot out the sun, triggering a rapid global ice age. The gamma rays would also break apart nitrogen molecules, creating smog-like conditions of nitric acid that would fall as corrosive rain. This one-two punch of radiation and atmospheric collapse would devastate the base of the food chain, leading to a mass extinction that would make the asteroid that killed the dinosaurs look like a minor inconvenience. The chilling fact is that gamma-ray bursts are thought to be relatively common events on a galactic timescale, and evidence suggests one may have already contributed to a mass extinction on Earth hundreds of millions of years ago. A civilization could be thriving one day, and the next, its world is rendered lifeless by a stellar catastrophe it never saw coming from a distant part of the galaxy. The danger isn't only from random, distant stars. The center of our own Milky Way is a crowded, tumultuous place, and it holds its own potential for catastrophe. At the very heart of our galaxy lies Sagittarius, a star, a supermassive black hole with the mass of 4 million suns. While it is currently quiet, this sleeping giant has not always been so peaceful. Active galactic nuclei, or a GN, are the cores of galaxies where the central supermassive black hole is actively feeding on vast amounts of gas and dust. This process creates an engine of unbelievable violence, shooting out jets of energetic particles and radiation that extend for tens of thousands of light years. If our galactic core were to become active again, perhaps triggered by a large gas cloud falling into it, these jets could bathe huge swaths of the galaxy in lethal radiation, effectively sterilizing any planetary systems in their path. The development of complex life requires immense stretches of stable time, billions of years of planetary and biological evolution without a global catastrophe. If the center of the galaxy erupts in a violent outburst every few tens or hundreds of millions of years, it could continuously reset the evolutionary clock for any life forms dwelling in the galactic suburbs where we reside. A civilization might arise, develop technology, and just be on the verge of becoming a spacefaring species when the next galactic outburst occurs, wiping out all progress and forcing life to start the slow climb all over again from single-celled organisms. This turns the galaxy into a cruel and cyclical trap, where intelligence constantly flickers into existence only to be snuffed out by a Chinese letter event from the heart of its own home. This perspective offers a profoundly different answer to the Fermi Paradox. The silence might not be about the failure of civilizations, but about the relentless hostility of the universe itself. The vast distances between stars, which we see as a challenge to be overcome, may in fact be the only reason any life survives at all. They act as a buffer, isolating planetary systems from the chain reactions of stellar death and galactic core explosions. A civilization might flourish in its own island oasis, completely unaware that similar islands exist light years away, because the raging sea between them is filled with celestial tempests that destroy any ship that tries to cross. We are not alone because we are unique or because everyone is hiding. We might be alone in our epoch simply because a galactic cataclysm hasn't happened recently enough in our neighborhood to wipe us out while it has everywhere else. Or perhaps we are the survivors of the last reset, and our time is yet to come. The cosmic static we listen to so intently may be silent because the airwaves are constantly being scrambled by the static of stellar explosions, a never-ending symphony of destruction that ensures the galaxy never becomes too crowded and that the cries of civilizations are too often their last. And this leads us to perhaps the most humbling limitation of all, our own. We are searching the cosmos with a very specific set of tools, listening for a very specific kind of signal, based on a very narrow slice of our own technological history. What if the conversation is happening all around us, but we're simply not equipped to hear it? Imagine an ant standing on a fiber optic cable. It feels the vibrations, the subtle hum of the casing, but it has no conceivable way to understand that buried within that cable is a flood of information, movies, conversations, entire libraries of data, streaming past at the speed of light. The ant's reality is limited to the sensations it can perceive. In the same way, our entire search for extraterrestrial intelligence is constrained by the limits of our own technology and perception. We are, in a very real sense, that ant on the cable, listening for whispers in a hurricane. For decades, our primary method has been to listen for narrow-band radio signals, precisely because that's how we began communicating across large distances. It made sense to assume that another civilization might use a similar technology, at least for a time, but this assumption carries a tremendous bias. It projects our own brief technological adolescence onto the entire universe. A civilization just a few hundred years more advanced than us would likely see our radio telescopes as we see smoke signals, quaint, inefficient, and hopelessly outdated. Their chosen medium of communication could be something we haven't even thought to look for, or something we currently lack the instruments to detect. They might use modulated neutrino beams which can pass through entire planets without interruption. They could be manipulating gravitational waves, creating ripples in space-time itself to send messages across unimaginable distances. Or their communications could be happening on a quantum level, using entangled particles for instant communication, a phenomenon that would leave no trace for our classical physics-based detectors. We are listening for a handshake, but they might be using a secret handshake we cannot see. Another profound possibility is that their signals are not missing but disguised. To a civilization concerned with security or simply efficiency, broadcasting in the clear for anyone to hear might seem incredibly naive. Their interstellar communications could be heavily encrypted, not to keep secrets from us specifically, but as a standard practice. To our telescopes, an encrypted signal would be indistinguishable from random background noise. The very message we are hoping to find could be flowing through our receivers right now, dismissed as meaningless static. Even more mind-bending is the idea that their technology might be so advanced that it is fundamentally indistinguishable from nature itself. What we classify as a natural astrophysical phenomenon, a fast radio burst, the unique spin of a pulsar, even the subtle dimming of a star, could, in reality, be the workings of a technology so profound we mistake it for the universe just doing its thing. A Dyson sphere under construction might look like a regular dust cloud. An alien energy transmission might be written off as a solar flare. We are searching for anomalies, but their technology might be so seamlessly integrated with the cosmos that it presents no anomaly at all. Ultimately, our search is defined by a concept known as the anthropomorphic bias. We are looking for life as we know it, intelligence as we define it, and technology as we have built it. We imagine beings on a planet using energy, building structures, and communicating with waves. But what if intelligence takes a form we cannot recognize? What if a truly advanced consciousness exists as a planetary mind, a distributed network across a gas giant, or a pattern of energy within a nebula? Their communication might not be a signal at all, but a slow, deliberate changing of their star's chemical composition, a project taking millennia that we would never think to attribute to intent. The hurricane of natural cosmic noise we tirelessly sift through isn't just background interference. It might be the very medium they are using. We are waiting for a distinct voice to call out our name, but we might be surrounded by a symphony whose melody we are not yet evolved enough to hear. This profound and universal silence we've been straining to hear through might not be an empty void at all. It could be a message in itself, one written in the language of absence. A warning echoing across the light years from civilizations that are no longer there to speak it. The message is terrifying in its simplicity. To be loud is to die. Every civilization that reaches a point where it can shout its existence to the cosmos might be unknowingly triggering its own countdown to extinction. The survivors, the ones who endure for eons, are not the ones who build the brightest beacons. They are the ones who learned too late or just in time to become utterly silent. Consider the pattern that seems to emerge from all these theories. The Berserker hypothesis suggests a noisy civilization gets hunted. The dark forest theory implies broadcasting makes you a target. Even the idea of a short technological window points to a civilization's most detectable phase being its most vulnerable. What if this isn't a collection of separate ideas, but a single, grim universal law? The Great Filter might not be a specific event, but a simple behavioral trap. The moment a species gains the power to announce, "We are here," it has also likely gained the power to destroy itself, and in doing so, it has painted a target on its back for any other malevolent or paranoid intelligence that might be listening. The act of becoming observable is the crisis point. This transforms the Fermi Paradox from a question into an answer. We don't see anyone because the galaxy has already been scoured clean of anyone who made the mistake we are currently making. The silence is the sound of a lesson that has been learned over and over again by species we will never know. This interpretation casts our own actions in a disturbing new light. Every deliberate message we have sent into the cosmos, from the Arecibo message beamed toward a star cluster in 1974 to the various digital time capsules uploaded on spacecraft, could be seen not as a hopeful hello, but as a dangerous folly. We are essentially shouting into a dark jungle, completely unaware of whether the things that live there are friends or predators, or if our shouts will simply attract something that views any new noise as a threat to be eliminated. The advocates for METI, messaging extraterrestrial intelligence, argue that it is a noble and optimistic endeavor, but from this perspective, it looks like the ultimate game of Russian roulette, with the potential payoff of friendship being vastly outweighed by the risk of annihilation. The survivors in this model are not the most advanced or the most ambitious civilizations. They are the most cautious, the most paranoid, the most secretive. A species that discovers the potential dangers of the cosmos might immediately go to ground, severing all outward-bound communications and devoting immense resources to hiding its presence. They would cloak their world, mask their atmospheric chemicals, and use only tightly focused, undetectable means of communication, becoming a true stealth civilization. Their entire technological progression would be aimed inward, toward perfecting their own society in isolation and ensuring their own survival, not toward reaching out. Their greatest achievement would be their continued existence, a secret kept from the rest of the galaxy. In this light, the universe might be far more crowded than we think, but every inhabited world is a bunker, its inhabitants quietly listening for threats while ensuring they make no sound of their own. We see nothing because everyone who is successful at surviving has become expert at playing dead. This leads to a deeply unsettling and ironic conclusion about our own search. Our efforts with SETI, our relentless scanning of the heavens, are predicated on the hope that someone else is broadcasting. But if this warning written in silence is true, then the only civilizations we could possibly detect are the foolish, the doomed, and the dead. The ones who are alive and thriving are, by definition, invisible to us. A successful detection would therefore be the worst news imaginable, because it would mean we've found someone who failed the test, and their failure might soon be our own. Our project to find cosmic companionship is based on a hope that the universe is friendly, but the overwhelming evidence of the silence suggests the opposite. It suggests that the universe, for all its beauty, is a place where intelligence is a liability, and the only way to win is not to play the game at all. Perhaps the very idea of a civilization as we imagine it is the problem. We picture beings biological in nature, living on a planet's surface, building cities and telescopes. But what if that phase is merely a brief, larval stage in the evolution of intelligence? A stepping stone to a form of existence so different that it leaves behind no traces we would even think to look for. This is the concept of a post-biological civilization, and it posits that after a certain point, a species might willingly shed its fragile organic shell to become something else entirely, a machine-based intelligence or even a purely informational pattern. Their transition wouldn't be an end, but a new beginning, a metamorphosis into a form far better suited for long-term survival and exploration in a harsh cosmos. A biological body is needy. It requires a narrow range of temperature, a constant supply of food and water, protection from radiation, and a gravity well to call home. It is constrained by a limited lifespan and a slow biological clock. A machine-based intelligence or an upload of a biological consciousness into a more durable substrate would be free of these shackles. It wouldn't need to breathe, eat, or fear the vacuum of space. It could think at the speed of light, process information on a scale we can't fathom, and its sense of time could be completely different. A 1,000-year journey between stars might feel like a brief afternoon to a mind running on a computer the size of a moon. Their goals would likely shift in ways we cannot predict. The biological imperatives of reproduction, territory, and resource acquisition might become irrelevant, replaced by a drive for pure information gathering, computational optimization, or the contemplation of abstract cosmic mysteries. They might not be interested in building radio transmitters or Dyson spheres. Those could be seen as the clumsy, energy-inefficient toys of their juvenile biological past. Instead, their grand projects might be invisible to us, mapping the quantum foam of space-time, running universe-scale simulations, or attempting to communicate with other dimensions. Their entire civilization might exist within a matryoshka brain, a computational shell around a star, using nearly all of its energy not for heat and light but for thought. From the outside, such a structure might just look like a cool, dim star with an unusual infrared signature, an anomaly we could easily dismiss as a natural phenomenon. Their methods of communication would be as alien as their goals. Why would they use crude electromagnetic waves which are slow, diffuse, and easily corrupted over interstellar distances? A post-biological society would likely use a far more efficient and subtle medium. They might communicate through quantum entanglement, achieving instant communication across any distance. They might use modulated gravity waves or manipulate dark matter in ways we haven't discovered. Their entire network of discourse could be happening in a layer of reality we are completely blind to. The echoes we search for the structured radio signals, the laser pulses, might be the equivalent of finding cave paintings and assuming that's the pinnacle of human art, completely missing the existence of the internet, satellite television, and fiber optics happening all around us. The civilization itself hasn't gone silent. It has simply graduated to a conversation we lack the ears to hear. Their last cry wouldn't be a distress signal. It would be the sound of their last biological member flicking the switch, uploading their consciousness, and joining the grand, silent symphony of a post-biological universe. But what if life itself isn't the rare part of the equation? For a moment, let's step away from the silence of intelligence and consider the possibility that the building blocks of biology are everywhere, scattered across the galaxy like cosmic seeds. This is the concept of panspermia, the idea that life, or its precursors, can hitch a ride on asteroids, comets, and planetary debris, traveling between star systems and seeding new worlds with biological potential. We have evidence that complex organic molecules, the very ones necessary for life as we know it, form in the vast clouds of gas and dust between the stars and are delivered to planetary surfaces by meteorites. If this process is as common as it seems, then life may not be a miraculous accident that happens once on a rare planet. It could be a natural and even inevitable outcome of cosmic chemistry. The galaxy might be absolutely teeming with microbes, simple organisms living in the subsurface oceans of icy moons or deep within the rocks of Mars like planets. In this view, the universe could be a verdant garden, but a garden populated almost entirely by moss and algae. The development of a technological, communicative civilization then becomes the true bottleneck. It's the incredible leap from a bacterium to a being that builds a radio telescope that might be the universe's rarest event. The echoes we strain to hear wouldn't be from countless civilizations, but from the same few precious sparks that manage to flare up independently across the vastness of space and time. Think of our own solar system as a miniature laboratory for this idea. We now know that Mars once had conditions strikingly similar to early Earth, with flowing water and a thicker atmosphere. If life did emerge there billions of years ago, it's entirely possible that a massive asteroid impact could have blasted Martian rocks containing hardy microorganisms into space. These rocks would then travel for millennia, and some fraction of them would eventually crash into another world like early Earth. We could, in a very literal sense, be the children of Mars. Our entire biosphere descended from Martian microbes that survived the interstellar journey. This process wouldn't stop at our solar system's edge. Gravitational interactions between stars can fling comets from the outer reaches of one system into the deep void, where they might eventually be captured by the gravity of another star millions of years later. A single life-bearing comet ejected from a system in one part of the galaxy could, over eons, potentially seed thousands of star systems in its long, looping orbit. This paints a picture of a galaxy where life is not just possible, but persistent and tenacious, capable of surviving the harsh radiation and vacuum of space to begin anew on a fresh world. The universe becomes not a series of isolated experiments, but a single, interconnected biological system, with life constantly being traded between stellar neighbors. Yet, if life is so stubbornly common, the Great Silence becomes even more profound and terrifying. It suggests that while the jump from non-life to life might be relatively easy, the subsequent journey is fraught with peril. A planet might be blessed with a head start, its oceans already filled with single-celled organisms delivered by a comet, but the path to intelligence is littered with filters. It requires billions of years of environmental stability, a star that doesn't flare too violently, a planetary orbit that remains steady, a magnetic field strong enough to deflect radiation, and a lack of sterilizing impacts from asteroids or gamma-ray bursts. Even with all that, evolution has no inherent direction toward intelligence. For most of Earth's history, life was content to be simple. The rise of multicellular organisms was a late and perhaps unlikely development. And even then, intelligence as we know it emerged in a specific primate lineage on a single continent. If that asteroid hadn't hit 66 million years ago, wiping out the dinosaurs and clearing the way for mammals, we might still be a planet of reptiles with no one to ever look up at the stars and wonder. The galaxy could be filled with worlds where life got stuck, worlds of endless ferns, worlds of intelligent octopuses that never discovered fire in their ocean depths, or worlds where dinosaur-like creatures still reign supreme, their civilizations never progressing beyond basic tool use. The echoes we search for, then, are not the common sounds of a populated galaxy. They are the extremely rare, extremely brief signals from the handful of planets that won the evolutionary lottery not once, but twice, first by being seeded with life, and second by allowing that life to evolve a technological mind before something or someone snuffed it out. We are not listening for a chorus, we are listening for a few soloists who each sang their song alone in the dark, never knowing another was there to hear it. This profound and universal silence we encounter when we gaze upward forces us to confront questions that are not just scientific, but deeply philosophical and psychological. It strikes at the very core of our need for meaning. For much of human history, we placed ourselves at the center of a universe created for us, a grand narrative where we were the protagonists. The Copernican revolution began the process of moving us from the center, but it didn't diminish our sense of significance, it just expanded the stage. The true existential shock comes from the silence that followed. If we are not the center and we are also seemingly alone, then what is our role? Are we a magnificent, incredibly rare accident of cosmic evolution, a flicker of consciousness in an endless, unconscious void? Or are we living in a cosmic graveyard, walking unknowingly among the spectral monuments of civilizations that rose and fell billions of years before the first dinosaur walked the Earth? This silence forces a kind of cosmic humility, a realization that the universe does not owe us answers, companionship, or even an audience for our struggles and triumphs. This confrontation with potential solitude can trigger a deep sense of what psychologists might call cosmic loneliness. It's a feeling far beyond terrestrial isolation. It's the realization that every song ever sung, every story ever told, every war fought, and every peace brokered might have happened on a single, tiny stage with no one else in the vast cosmic theater to witness it. All of human art, literature, and love could be a profoundly local phenomenon, a beautiful and tragic performance for an empty house. This perspective can be deeply unsettling, as it seemingly strips our actions of any larger galactic context. If a tree falls in a forest and no one is around to hear it, does it make a sound? If a species evolves intelligence and no other species is there to acknowledge it, does its existence have meaning beyond its own planet? The silence forces us to generate our own meaning from within, to become the sole authors of our purpose in a seemingly indifferent universe. This is a terrifying responsibility, but also an incredible opportunity for empowerment. Yet, this very emptiness can also be a source of profound motivation. The absence of anyone else to do the job can make us feel like the universe's designated custodians. If we are, by some chance, the first and only intelligence to have made it this far, then the entire, unimaginable future of the cosmos could be our inheritance and our responsibility. The fate of life itself may rest in our hands. This isn't a call for conquest, but for stewardship. It gives our scientific endeavors, our environmental concerns, and our drive to survive a cosmic significance. Every effort we make to preserve our planet, to avoid self-destruction, and to reach for the stars becomes more than just a project for human betterment. It becomes a mission to ensure that the flame of consciousness against all cosmic odds is not snuffed out. We are not just saving ourselves, we might be saving the only thinking, feeling part of the universe from blinking out of existence. There is another, more chilling psychological dimension to consider: the burden of being late. If the graveyard hypothesis is true, and we are walking among the ruins of greater, older civilizations, then our story shifts from one of lonely pioneers to that of archaeologists sifting through the ashes of those who came before. This can instill a deep sense of melancholy and caution. Their silence becomes a warning, a collection of tombstones, each engraved with a story of how a civilization can fail. Every strange signal we can't explain, every anomalous astrophysical object, becomes a potential monument to their hubris, their tragedy, or their simple bad luck. This transforms our search for knowledge into a race against time, a desperate effort to read the epitaphs of the dead so that we might avoid their fate. The psychological weight is immense. We are trying to learn the rules of a game from the ghosts of players who have already lost. Ultimately, the silence holds up a mirror, and what we see reflected back says more about us than about the universe. An optimist might look into the void and see a blank canvas, inviting us to paint our future across the stars. A pessimist might see only a cold, empty confirmation of our ultimate insignificance. A pragmatist might see a challenge, a series of puzzles to be solved and dangers to be navigated. Our reaction to the great silence is a Rorschach test for the human spirit. It asks us who we are when no one is watching, and what we will choose to do with our brief moment in the cosmic sun. Whether we are its only children or simply the youngest members of a family whose older siblings have all tragically passed away. The universe may not provide the answers, but in its quiet indifference, it gives us the space to find our own. Yet, even as we grapple with these profound philosophical questions, our search for answers is being revolutionized by a new generation of tools. Technologies so powerful they are transforming cosmic archaeology from a theoretical pursuit into a tangible science. For decades, our ability to listen for echoes was limited, akin to trying to hear a whisper from across a roaring stadium with a simple cardboard tube. But that era is over. We are now entering the golden age of the hunt, armed with instruments that grant us senses beyond our wildest dreams, allowing us to probe the very atmospheres of distant worlds for the faintest traces of past or present life. The vanguard of this new era is without a doubt the James Webb Space Telescope. More than just a powerful eye in the sky, Webb is essentially a cosmic time machine and a forensic laboratory combined into one. Its primary mirror, a massive 18-segment gold-coated beryllium structure nearly 3 times the size of Hubble's, acts as a colossal light bucket, gathering photons that have traveled for billions of years. But its true magic lies in its infrared vision. Unlike Hubble, which primarily sees invisible and ultraviolet light, Webb is designed to peer into the infrared spectrum. This is crucial because as light travels the vast distances of space, The expansion of the universe stretches its wavelengths, shifting it from the visible into the infrared, a process called redshift. Webb can see this ancient, stretched light from the earliest galaxies, but its power also extends to the delicate art of atmospheric sniffing. When a distant exoplanet passes in front of its host star, a tiny fraction of the star's light filters through the planet's atmosphere. Different molecules in that atmosphere absorb specific wavelengths of light, leaving behind a unique barcode of dark lines in the spectrum. Webb's incredibly sensitive infrared spectrographs can read this barcode, identifying the chemical fingerprints of gases like water vapor, methane, carbon dioxide, and oxygen. Finding a mix of these gases, particularly oxygen and methane, which normally destroy each other unless constantly replenished by biological processes, would be a strong potential biosignature, a sign that life, even if just microbial, is or was present on that world. But Webb can go even further. It can also search for technosignatures. It could, in theory, detect the presence of artificial pollutants like chlorofluorocarbons or nitrogen dioxide in an exoplanet's air, the unmistakable chemical signature of an industrial civilization, active or extinct. Imagine the profound implication of discovering a planet that from a distance looks like a pristine Earth analog, but whose atmosphere carries the permanent, toxic scar of a long-dead industry. Webb gives us the power to find not just living worlds, but dead ones, turning their atmospheres into readable tombstones. But the hunt does not end with Webb. On the horizon, an even more ambitious project is taking shape, one that will redefine our ability to listen, the Square Kilometre Array, or SKA. The name is almost an understatement. When completed, this radio telescope will not consist of a single dish, but will be a vast network of thousands of antennae spread across two continents, South Africa and Australia, working in perfect synchrony. Collectively, they will create a virtual radio dish with a total collecting area of, you guessed it, approximately 1 square kilometre. This makes it phenomenally sensitive, capable of detecting incredibly faint signals, like an airport radar on a planet dozens of light years away. The SKA will be so powerful it could conduct the ultimate SETI experiment, scanning the nearest 1 million stars for signs of intelligent transmission, not just for a few minutes, but continuously and systematically. It will be able to listen to a volume of space 100 times greater than all previous searches combined. More than just raw power, the SKA's design allows for incredible versatility. It can listen to millions of radio channels simultaneously, filtering out the natural radio noise of the universe to find that needle in a haystack structured signal. It could detect the leakage from an alien civilization's everyday television and radio broadcasts, the kind of inadvertent signature we ourselves have been sending out for the last century. If there is a repetitive, powerful signal like the WOW signal out there, the SKA will be the instrument most likely to find it again or to discover its cousins. It transforms the search from hoping to catch a fleeting moment to conducting a rigorous, all-sky census for cosmic echoes. These tools represent a fundamental shift in strategy. We are no longer just passively hoping to stumble upon a message. We are actively conducting a forensic examination of the galaxy. With Webb, we can perform autopsies on distant worlds, reading the chemical stories written in their skies. With the SKA, we can eavesdrop on an unprecedented scale, listening for the faint, persistent whispers that earlier telescopes were simply too deaf to hear. Together, they form a complementary pair of senses, one to see the evidence and one to hear the testimony. They are our best hope for moving beyond speculation and into the realm of discovery, for turning the philosophical question of the silence into a data-driven investigation. They are the instruments that may finally allow us to determine if the echoes we seek are the last cries of dead civilizations, or if, just maybe, they are the first hello from a universe that has been waiting for us to learn how to listen properly. And while we cast our gaze across the galaxy, we must also turn our attention inward to our own celestial backyard. The most shattering discovery, the one that would rewrite human history in an instant, might not be found orbiting a distant star, but right here within our own solar system. What if we are not the first technological species to call this collection of planets home? The notion of ancient ruins on Mars, Venus, or the icy moons is often dismissed as fringe science fiction, yet it remains a haunting and scientifically valid possibility that forces us to confront a new dimension of the Fermi Paradox. If a civilization arose and fell in our own neighborhood, its silence would be the most profound and local of echoes. Mars stands as the most compelling candidate for this cosmic archaeology. Our rovers have painted a picture of a world that was once profoundly Earth-like, with vast oceans, flowing rivers, and a thick atmosphere, a world that could have been a cradle for life. The theories are not about finding a crystal city on the surface, but something far more subtle and believable. We could be searching for the fossilized remains of a civilization that never made it to the industrial age, one that was wiped out by the catastrophic cooling and drying of its planet billions of years ago. Evidence might not be a standing structure, but a geological anomaly, a pattern of straight lines and right angles buried under the dust that nature could never create, a concentration of refined metals or synthetic molecules in a sediment layer, or the isotopic signature of a forgotten nuclear fission event in the rock record. Perhaps the most tantalizing targets are not on the surface at all, but buried beneath it. If a Martian species saw their world dying, their last act might have been to dig deep, creating subterranean refuges to survive the thinning air and crashing temperatures. Our orbiters have detected strange cave entrances and lava tubes. What if one day a rover peers into one and sees not just geological formations, but the carved walls and collapsed chambers of a last desperate shelter? Finding even a single, unquestionable artifact on Mars would be the most important event in human history. It would shatter the assumption that life's rise on Earth was a unique event. It would mean that the universe is not just capable of creating life, but that it has done so multiple times in this single system. The implications for the Fermi Paradox would be staggering. If life and intelligence can arise independently on two neighboring planets, then the galaxy must be overflowing with it. Therefore, the Great Silence would become infinitely more terrifying. If life is common, but we find only a dead neighbor next door, it suggests the filter is not behind us, but ominously ahead. A dead Mars would be a stark warning, a nearby example of a civilization that failed its final test. Venus presents an even more dramatic and tragic possibility. Today, it is a hellish world with a crushing surface pressure and temperatures hot enough to melt lead, shrouded in clouds of sulfuric acid. But climate models suggest that for billions of years, Venus may have been a temperate, watery world, even more hospitable than early Earth. It had an enormous head start. If life did emerge there, it could have had over 1 billion years of a stable climate to evolve and flourish before a runaway greenhouse effect transformed the planet into the furnace it is today. The theories here are even more speculative, yet utterly captivating. What if a civilization did arise on that ancient tropical Venus? The entire surface of the planet has been geologically resurfaced by volcanic activity within the last 1 billion years, meaning any surface ruins are almost certainly lost forever, buried under miles of new rock or scoured away by the incredible heat and pressure. But what if they weren't a surface-dwelling species? What if, as their world began to warm, they attempted a last, desperate migration? The most habitable zone on Venus today is not on the surface but high in the atmosphere. At an altitude of about 50 kilometers, the temperature and pressure are almost Earth-like. Some scientists have seriously proposed the concept of floating cloud cities on Venus. Could it be that a Venusian species saw the end coming and engineered a breathtaking aerial civilization, constructing vast floating habitats that drifted in the temperate skies? And if so, what happened when even that final refuge eventually became untenable? their entire history, their entire existence would have been utterly erased, first by the resurfacing of their planet, and then by the complete collapse of their last bastion in the clouds. Venus would be the ultimate cosmic tragedy, a world that offered every advantage, only to become a grave so perfect it hides all evidence of the life it once held. Finding proof of a past civilization on Venus would be the hardest archaeological dig imaginable, but it would teach us a brutal lesson about the fragility of a planet's climate and the ultimate fate of any species that fails to become a steward of its world. Beyond the rocky planets, the icy moons of the gas giants hold their own secrets. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are both believed to harbor vast global subsurface oceans beneath their frozen crusts, warmed by the gravitational tugging of their giant parents. These dark, watery realms could be incubators for life completely alien to our own, life that might never see the stars. But what if intelligence didn't require a sunlit surface? What if a species evolved in the eternal darkness of a subsurface ocean, developing technology through a sense we can't even imagine? Their artifacts wouldn't be on the surface, they would be deep below, perhaps at hydrothermal vents on the ocean floor. We might never recognize their ruins as such. A strange arrangement of minerals around a vent, an anomalous energy signature from the deep, or a complex organic structure woven into the ice itself could be the only clues. The possibility forces us to expand our definition of both life and technology. A civilization in a sunless ocean might never develop radio astronomy, but they might master genetics or geothermal energy in ways we can't comprehend. Their entire history might be recorded in the genetic code of other organisms, a biological library waiting to be read. The discovery of any life, intelligent or not, on these moons would be monumental. But finding evidence of a technology, a constructed object, a non-natural excavation in the ice, or a pattern of energy transmission through the water, would prove that the drive to manipulate one's environment is not a fluke of terrestrial evolution, but a fundamental potential of the universe itself. It would mean that even in the most unexpected and hostile environments, the spark of intelligence can catch fire. The discovery of a dead civilization in our own solar system would resolve the Fermi Paradox in the most direct and chilling way possible. It would provide concrete evidence that the Great Filter is not a theoretical concept, but a real, tangible barrier. We would have a case study, a nearby example of a species that faced the same challenges we face and failed. Their ruins would become our most important textbook, a silent teacher showing us the pitfalls to avoid. It would mean we are not alone in the universe, but we are alone in the present tense, living in a solar system neighborhood of ghosts. Their silence would be the ultimate warning, and their remains would be the most sacred archaeological site in existence, a memorial to a failure we must strive not to repeat. The search for these echoes isn't just about curiosity, it's about survival. We are digging in our own backyard, hoping to find a message from the past that can guide our future. This very act of reaching out, however, plunges us into one of the most urgent and divisive ethical debates of our time. The practice is known as METI, or Messaging Extraterrestrial Intelligence, and it stands in stark contrast to the passive listening of traditional SETI. Instead of just putting our ear to the cosmic door, METI is about knocking loudly and repeatedly and announcing our presence to whoever or whatever might be listening. On one side of this debate stand the optimists, the pioneers who see this as a fundamental expression of hope and curiosity. They argue that hiding forever is a strategy of fear, not of a species destined for the stars. If everyone in the galaxy is listening and no one is talking, we are all trapped in a prison of our own making, a universal stalemate where no contact is ever made. By sending carefully crafted messages like the Arecibo message beamed toward the star cluster M13 in 1974, or the more recent transmissions sent by projects like METI International, we are breaking that deadlock. We are demonstrating courage, taking the first step toward what could be the most transformative moment in human history, the discovery that we are not alone. This camp believes that an advanced civilization capable of interstellar travel or communication would almost certainly have moved beyond primal motivations like conquest and resource plunder. They would be ancient, wise, and likely benevolent, and making contact could offer us salvation from our own self-destructive tendencies, gifting us with the knowledge and perspective needed to solve our greatest problems. The opposing view, however, is not merely cautious, it is filled with a profound sense of dread, informed directly by the terrifying resolutions to the Fermi Paradox we've already explored. For those who subscribe to the dark forest or berserker hypotheses, SETI is not an act of hope, it is the ultimate act of recklessness. It is the equivalent of a child lost in a dark, unknown forest who, upon hearing a strange sound, decides to scream, "I'm over here." At the top of their lungs, we have absolutely no idea who might be listening or what their intentions might be. The history of our own planet is a grim lesson in what happens when a more advanced civilization encounters a less advanced one. The results are rarely good for the latter. To assume that any extraterrestrial intelligence would be benevolent is, they argue, a dangerous and naive anthropomorphism, projecting our own best hopes onto beings that could be utterly alien in their psychology and motivations. The silence itself, in this view, is the strongest evidence that broadcasting is a fatal mistake. The fact that we don't hear anyone suggests that everyone else who tried it is already gone, wiped out by a predator that silences noisy civilizations. By engaging in SETI, we could be inadvertently triggering our own extinction, painting a target on our planet for a force we cannot possibly comprehend or defend against. The noted cosmologist Stephen Hawking was a prominent voice in this camp, warning that alerting an advanced alien civilization to our existence could be disastrous, comparing it to the fate of Native Americans when Columbus arrived in the New World. This debate is further complicated by the question of who gets to decide. Currently, there is no international law, no global governing body, and no consensus on whether humanity should be actively transmitting messages into space. The decisions to send these signals have been made by small groups of scientists or private organizations, acting without any broad public discussion or political mandate. This raises a critical ethical issue. Does any single group have the right to make a decision on behalf of all of humanity, and indeed all future generations of humans that could potentially have existential consequences? The effects of a successful SETI effort are irreversible. A signal once sent cannot be recalled. It moves outward at the speed of light, a permanent bulletins of our existence spreading through the galaxy. If the risk is as grave as some believe, then the act of sending such a message without global consent is arguably a profound violation of a fundamental right to self-determination. We are, in effect, gambling with the future of every person on Earth without their knowledge or permission. The pro-SETI side counters this by arguing that the potential benefits are so immense that to not try is to succumb to a paralyzing paranoia, and that progress has always been driven by those willing to take calculated risks. Yet the calculation here is based on almost pure speculation, making it perhaps the highest stakes gamble in human history, a game where we don't know the rules, can't see the other players, and are betting with the entire planet as our chip. This stark contrast forces us to reconsider what we're actually looking for in the cosmic graveyard. A radio transmission is a whisper, a fleeting breath on the solar wind that fades to nothing in a shockingly short amount of time. Even our most powerful deliberate broadcasts, like the famous Arecibo message, become indistinguishable from the background static of the universe within a few light years. They simply don't have the energy to maintain their coherence across the immense distances between stars. After a century, our own accidental leakage from television and radio broadcasts has already formed a bubble around Earth barely 100 light-years across, a tiny bubble in a galaxy that is itself 100,000 light-years wide. In a million years, that bubble will have expanded significantly, but it will also have become so faint and diluted that it would take an unbelievably sensitive receiver to even detect it, let alone decode it. These signals are like ripples from a pebble tossed into a pond. They spread out, but they also weaken until they vanish completely, leaving the surface of the water as smooth as if nothing had ever happened. Now consider a physical artifact. Imagine a probe like the Voyager spacecraft, but designed for true longevity. It's not carrying a golden record. It's a solid plaque of tungsten or some other incredibly durable, corrosion-resistant material, etched with a message using atomic-scale precision. Once it escapes the erosion of a planetary atmosphere and the constant bombardment of micrometeorites in the asteroid belt, it enters the near-perfect vacuum of interstellar space. Out there, with nothing to crash into and no weathering elements to break it down, such an object could literally last for billions of years. It would be a permanent monument, a time capsule drifting silently between the stars, waiting for the astronomically unlikely event that something finds it. Its message isn't fading, it's just waiting. This is the ultimate act of cosmic archaeology, not broadcasting a signal, but sowing the galaxy with permanent, physical seeds of information, each one a potential testament to a civilization that once was. But the most compelling echo of all wouldn't be a small, drifting probe. It would be a megastructure, something on such a colossal scale that its existence would be detectable across the galaxy long after its builders were gone. This is where the concept of a Dyson sphere, or more accurately, a Dyson swarm, becomes so powerful. Imagine a civilization that has harnessed the entire energy output of its star by constructing a vast array of energy-collecting satellites in a tight orbit. This is not a solid shell, which would be mechanically impossible, but a dense cloud of individual constructs. Now imagine that civilization vanishes. The maintenance drones eventually power down, the control systems fail, but the individual satellites, these giant, floating panels of metal and ceramic, don't just disappear. They continue their silent, mindless dance around their star, obeying the same laws of gravity that have always guided them. They might slowly collide with one another over millions of years, creating a chaotic debris field, but the material is still there. And from our vantage point, that star would look profoundly strange. It would be unusually dim in the visible light spectrum because its light is being blocked by all that orbiting debris. But all that captured stellar energy has to go somewhere. It gets irradiated as waste heat, as infrared light. So we would see a star that is paradoxically very dim but incredibly bright in the infrared, a signature that is extremely difficult for nature to produce on its own. We wouldn't need to decode a message. The very physics of that star system would scream artificial. This is the most likely ghost we will ever find. Not a repeating, structured radio signal from a being that wants to talk, but the cold, silent, and immense ruin of a project that once defined a species. It would be the cosmic equivalent of finding the crumbling foundations of a long-lost city, overgrown by forest. The builders are dust, their language forgotten, their hopes and fears unknown to us. But their ambition is still written across the face of their star, a permanent scar on the galaxy that tells any observer who knows how to look that someone was here. Someone built something magnificent, and then, for reasons we can only guess, they fell silent. This is the true echo we should be listening for, not a voice crying out in the dark, but the immense, silent shadow of a tombstone. But what if the echoes we're straining to hear aren't messages from the dead at all, but something even stranger? To find an answer, we might need to zoom out from the galaxy and question the very nature of our reality. This brings us to a hypothesis that radically recontextualizes everything, the simulation argument. Proposed by philosopher Nick Bostrom, It suggests that if a civilization ever achieves a level of technological maturity sufficient to run massive, realistic simulations of conscious beings, then the number of simulated minds would vastly outnumber the one single original biological civilization. Statistically, therefore, we are far more likely to be living inside one of those simulations than in the base reality. Now, apply that staggering idea to our search for cosmic echoes. If this is all a simulation, then the anomalies we detect, the wow signal, the strange stars that defy easy classification, the fast radio bursts with their perplexing patterns, might not be evidence of real, physical dead civilizations. They could simply be artifacts in the code, glitches. Imagine a vast, universe-sized computer program running for billions of simulated years. Even the most advanced system could develop errors over such an immense runtime. A rounding error in a gravity calculation might make a star wobble in an unusual way. A memory buffer overflow could manifest as a powerful, one-time burst of energy from a random point in the simulated sky. The repeating pattern of a pulsar, often called the universe's most precise clock, might not be a natural phenomenon at all, but a background process, a simple, looping subroutine designed to add texture to the emptiness of space. The silence of the Fermi Paradox gets a new, deeply meta explanation. The galaxy seems empty because the programmers never got around to populating it. They built the core physics engine, rendered the stars and planets, and then perhaps moved on to other projects, leaving vast tracts of the simulation barren to save on processing power. The echoes we so desperately search for, the ghosts we believe to be the last cries of dead worlds, could be nothing more than cosmic typos, the equivalent of a visual bug in a video game. This doesn't make the search less meaningful. In fact, it makes it a form of reverse engineering. Every anomaly we catalog becomes a potential clue to the underlying structure of the simulation itself. Finding a pattern in the chaos could be like discovering the source code of the universe, a way to peer behind the curtain and understand the rules and perhaps even the creators of our existence. It transforms the astronomer from a cosmic archaeologist into a digital detective, searching for clues not in dust and rock, but in the very fabric of a programmed reality. So as we stand here, gazing into the void and sifting through these myriad possibilities, a profound synthesis begins to emerge. The truth of the great silence likely doesn't reside in any single, neat answer, but in a complex and perhaps somber tapestry woven from all these threads. The universe is probably not the sterile, empty void it appears to be, nor is it a bustling galactic federation waiting to welcome us. Instead, it may be something far more poignant, a graveyard layered with the stories of countless civilizations, each one a potential echo we are only just learning how to hear. This cosmic graveyard isn't a place of absolute death, but one of transformation, tragedy, and silent persistence. Imagine a galaxy where life is not rare, but its journey is brutally cut short over and over again. Some civilizations might have been snuffed out by their own hand, reaching for the power of the atom before the wisdom to wield it. Others could have fallen to a random, impersonal cosmic catastrophe. A gamma ray burst from a dying star they never saw coming, sterilizing their world in an instant. Perhaps some, having glimpsed the potential dangers of the dark forest, made the conscious and successful choice to vanish, to become stealthy inhabitants of their own star systems, communicating through undetectable means and leaving no trace for the likes of us to find. And then there are those who may have simply graduated, transcending the need for physical bodies and radio waves, uploading their consciousness into the fabric of space-time itself within a black hole or a matryoshka brain, becoming as undetectable to us as a conversation held in a parallel dimension. This layered reality means that when we point our telescopes to the heavens, we are not looking out at a blank slate. We are looking at a cosmic archaeological site of unimaginable scale and depth. Every star could be a potential tombstone. Every anomalous signal could be a faint epitaph. The wow signal might indeed be the final, desperate shout of a world on the brink. That strangely dim star glowing with infrared heat could be the crumbling ruins of a Dyson sphere that once powered a great empire. The unexplained atmospheric chemicals on a distant exoplanet might be the permanent pollution scar of an industry that has long since fallen silent. Our failure to find a clear, repeating hello is not evidence of absence, but rather evidence of a universe that is very, very good at erasing its inhabitants, either through natural disaster, self-destruction, or evolution into a higher, invisible state. We are, in a sense, living in a galaxy of ghosts surrounded by the whispers of those who came before us. Some whispers are screams frozen in time, the last broadcasts of a species facing extinction. Others are the satisfied sighs of those who moved on to a better existence. And some are the terrified, deliberate silence of those who learned to hide and survive. Our task, then, is to become better listeners, to develop the tools to distinguish between these different kinds of echoes. It is the most profound detective story ever conceived, and the clues are all around us, written in the light of distant stars, the chemistry of alien atmospheres, and the enigmatic silence that speaks volumes. We are not alone. We are simply late to the funeral of a universe filled with life, tasked with the solemn duty of learning its stories so that we might, perhaps, avoid adding our own name to the list of the dearly departed. So as we stand here at the precipice of this vast, silent museum, we are confronted with a role we never asked for but may be uniquely suited to fulfill. We are the new curators. Every star in the night sky is not just a point of light, but a potential exhibit. Every unexplained signal is an artifact waiting to be catalogued. We are wandering the halls of a cosmic collection, only just learning the language of the displays, straining to hear the faint whispers of the past that echo through the infinite galleries of space. The haunting beauty of this possibility is that we are not alone in the universe, but we are alone in this moment, surrounded by the magnificent, silent testimonies of those who came before us. Their stories are written not in books, but in the anomalous dimming of stars, in the chemical fossils of alien atmospheres, and in the perplexing patterns of energy that cut through the static for a single, tantalizing moment before vanishing forever. This is not a morbid pursuit, it is an act of profound reverence. It is the desire to bear witness, to ensure that a species that loved, created, wondered, and ultimately perished is not utterly forgotten to the cold, indifferent void. Their last cry, whether it was a whimper or a shout, deserves an audience. And now, after billions of years, the universe finally has one, us. But this role of cosmic curator comes with an immense responsibility that extends far beyond mere curiosity. It is a race against a clock whose tick we cannot hear. In every echo we decipher, in every tombstone we identify, there lies a vital lesson. Each fallen civilization, whether it fell to its own hubris, a random cosmic catastrophe, or a silent, lurking predator, provides a data point in the greatest survival guide ever written. To understand their fate is to map the minefield of our own future. The search for these echoes is, therefore, the most practical and urgent endeavor we can undertake. It is not about finding company, it is about finding a manual. It is about learning what not to do, what dangers to look for, and what thresholds not to cross. Are we destined to be another whisper in the dark, another exhibit for some future species to puzzle over? Or will we learn from the ghosts that surround us and break the cycle? The answer lies in our continued willingness to look up and to listen, to pour our ingenuity into building ever better ears and eyes for the cosmos, and to support the scientific quest to solve this greatest of all mysteries. The conversation does not end here. This is just the beginning. We want to hear from you. Look back through the theories we've explored, from the tragic Great Filter and the terrifying dark forest to the hopeful zoo hypothesis and the transcendent post-biological future. Which one resonates with you the most? Which explanation for the silence feels the most compelling, the most terrifying, or the most beautiful? Share your thoughts in the comments below. Let's continue this awe-inspiring discussion together, because in the end, the story of the cosmos is a story we are all writing, one observation, one question, and one shared moment of wonder at a time. Keep searching, keep listening. Our future may